Welcome back. Now that we understand how pressure and density affect aircraft performance, it's time to look at how they shape weather systems. In this video, we'll explore pressure systems, how they form, how they move, and what they mean for you as a pilot. Let's start with the basics. A pressure system is a large-scale region of the atmosphere where the pressure is either higher or lower than the surrounding area. These systems drive most of the weather on Earth. There are two main types: high-pressure systems and low-pressure systems. Each one behaves differently and affects flying in different ways. Let's begin with high-pressure systems, also known as anticyclones. In these systems, air descends from higher altitudes and spreads out along the surface. This descending air suppresses cloud formation, which is why high-pressure systems usually bring clear skies and calm weather. In the northern hemisphere, air around a high-pressure system rotates clockwise and moves outward from the center. In the southern hemisphere, it's the opposite: rotation is counterclockwise. This is due to the Coriolis effect, caused by Earth's rotation. Because high-pressure systems are associated with sinking air, they generally bring stable flying conditions. That means good visibility, minimal turbulence, and dry air. However, they can also create low-level wind shear near the surface, especially near the edges. Now let's look at low-pressure systems, also called cyclones. In these systems, air converges at the surface and is forced upward. As the air rises, it cools and condenses, forming clouds and precipitation. That's why low-pressure systems are linked to unsettled weather. In the northern hemisphere, low-pressure systems rotate counterclockwise and pull air inward. Again, in the southern hemisphere, this is reversed. The rising air leads to instability, which can result in clouds, rain, storms, and even severe turbulence. Low-pressure systems are common near fronts, where warm and cold air masses meet. These boundaries can trigger significant weather changes: sudden wind shifts, temperature drops, thunderstorms, or fog. As a pilot, knowing where fronts lie is key to flight planning. Let's talk about the isobar pattern. Isobars are lines of equal pressure on a weather chart. When isobars are close together, that means a steep pressure gradient, which results in strong winds. When they're spread out, winds are lighter. The steeper the pressure gradient, the faster the air moves. This affects takeoffs, landings, cruise stability, and even fuel consumption. Reading isobars and estimating wind strength is a fundamental skill for every pilot. The space between isobars also shows how dynamic the system is. A tight pattern around a low indicates strong cyclonic activity. Expect turbulent air and possible thunderstorms. A wide, gentle pattern around a high suggests calm and stable conditions. Pilots should also be aware of pressure troughs and ridges. A trough is an extended area of low pressure, usually bringing clouds and rain. A ridge is an extended area of high pressure, bringing clear skies and stable weather. Troughs often signal the arrival of a cold front or the start of deteriorating conditions. You'll hear terms like approaching trough in weather briefings. When you do, expect increased cloud cover, changing winds, and lower visibility. In contrast, when a ridge is forecast, you can plan for a smoother ride. These are often found behind cold fronts, where high pressure is rebuilding. Knowing when and where these features are moving can help you avoid rough flying. So how do pressure systems move? Generally, they travel from west to east in the mid-latitudes, following the jet stream. The speed and path depend on the upper-level winds and temperature contrasts. Pilots can track these with surface charts and forecasts. The interaction between highs and lows creates wind flow across continents. Air moves from high to low pressure, but is deflected by the Coriolis effect. This results in the circulation patterns we see on global and regional weather maps. Understanding how these systems move helps with route planning, fuel estimation, and turbulence avoidance. For long-distance or IFR flights, it's crucial to check upper-level charts to see how pressure patterns will evolve during your route. Let's connect this to METARs and TAFs. When a TAF mentions tempo or BECMG, that often reflects pressure system movement. A shifting wind direction or falling pressure trend in a META may mean a low-pressure system is approaching. As a pilot, your job isn't just to react to weather, it's to anticipate it. Knowing how pressure systems develop and move gives you a huge advantage. You'll spot trouble before it becomes a problem and adjust your plan with confidence. High-pressure systems bring the best flying weather, but may trap pollution or fog in valleys due to temperature inversions. Low-pressure systems bring dynamic, challenging conditions, but also the chance to build valuable experience if managed properly. Let's recap. High pressure equals sinking air, clear skies, clockwise flow. Low pressure equals rising air, clouds, and rain, counterclockwise flow. Close isobars equals strong winds. Troughs and ridges signal changes ahead. Pressure systems are the engine behind most weather. They control wind, cloud formation, precipitation, and turbulence. Mastering this topic helps you become a smarter, safer, and more confident pilot in any environment. In the next episode, we'll continue with pressure systems, part 2. We'll dig into cold and warm fronts, occlusions, and how to recognize dangerous conditions like embedded thunderstorms or squall lines. You don't want to miss this one. See you in Meteorology number 06, Pressure Systems, part 2.